Hello and welcome everyone. This is Mohammad Izamam from Saimedha Ecet Coaching Center Koti, Hyderabad. Saimedha Koti, Hyderabad is providing a golden opportunity to all the Ecet 2024 and as well as Ecet 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, Saimedha Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. ర్యాంక్స్ గురించి చెప్పాలంటే Saimedha Koti Hyderabad లో every single year we have proven that maximum ranks in all the branches EC, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous Ecet examination questions will be explained by expert faculties. My dear students, gurtu pettukondi, only previous year competitive examination questions korake separate course untadi, pay cheyalsi untadi baita market lo, kani Saimedha Koti Hyderabad lo free of cost we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous Ecet examination questions with which you can understand the level of teaching, the expertise which is there in the Saimedha Koti Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the Ecet 2024 and Ecet 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Hi, hello everybody. Welcome back to the sessions of PYQs. Now let us see the topic called Theodlite surveying here. The very first question comes like the sum of exterior angles of a closed traverse is equal to dash right angles when n is the number of its sides. So we do know, if you observe any traverse, if you do know, see here, this is a traverse, okay, these are the exterior angles, these are the exterior angles, right, these are the interior angles, okay, these are the interior angles, okay. Now for these interior angles or exterior angles, after finding out all these interior angles or exterior angles, we can cross check whether we found out the correct interior or exterior angles by having a cross check. Now what is the cross check here? For interior angles, the cross check is for interior angles, the cross check is 2n minus 4 into right angles, okay. Likewise for exterior angles, it will be 2n plus 4 into 90 degrees, that is right angles, okay. Now here the question is all about, I think, exterior angles, right? So here he is asking about the exterior angle summation. So for exterior angle summation, we can clearly take it like 2n plus 4 into right angles, where n is the number of sides here. So this is 1, 2, 3, 4, this is 4, right? Okay, so you can make a cross check here, okay. So 2 into 4 plus 4 into 90, so this gives us the exterior angle summation, okay. So for a closed traverse only this will be able to possible, because for a closed traverse only we will be able to find out an interior or exterior angle, okay. So clear answer here is 2n plus 4 into 90 degrees, that is 2n plus 4 into right angles, okay. So let us see next question. A line which passes through the optical center of the objective and also through the intersection of the crosshair is called. See, for example, if this is a telescope of an instrument, this E is a telescope of an instrument, okay, we will be able to see some optical center here, okay, and we will be able to see the crosshairs of the diaphragm and we will be able to see the crosshairs of objective lens. Now what is the question he says here? A line which passes through the optical center of the objective, so a line which passes through the optical center of the objective, okay, and also through the intersection of the crosshair, so from this point to this point, okay, of crosshair is called. See here, this line he haven't said like this line is having its continuation. He only said the line is passing through optical center of the objective and also through the intersection of crosshair, okay. So that means here the line is restricted to some distance, okay. So when the line is restricted to some distance and that too within the telescope, we will be calling it as an axis of telescope, okay. If the line is having its continuation, then this line, total continuation line, we do call it as line of collimation, or we can also call it as horizontal axis, right? When you transit the telescope of a theodolite, you have to rotate the telescope about. So here we have to understand two definitions here, what is transiting and what is swinging, right? So now see here, I have said two terms like transiting and swinging. Now transiting will be happening on vertical plane, the transiting will be happening on vertical plane, okay, happens in vertical plane, okay, vertical plane, okay, and the swinging will be happening in horizontal plane, horizontal plane. Here this happens on horizontal axis, that means here the reference is horizontal axis, and here the reference is here vertical axis, vertical axis. Now very simple to understand here. Now see, there will be a horizontal line, there will be a horizontal line on which this will be getting supported, and this telescope will try to swing in the vertical plane. So that's what I have written here. It will be rotating, that means it will be happening, the angle adjustment can be happening in the vertical plane, but this will be the vertical movement, or if you observe the vertical rotation of the telescope which is happening in the vertical plane, will be observed on a horizontal axis called Trunian axis, okay. Now see here, when you transit the telescope, transiting means rotation of telescope in the vertical plane, okay, transiting means rotation of telescope in the vertical plane. You rotate the telescope about, so rotation is happening in the vertical plane and rotation is happening about a horizontal axis, okay. So rotation is happening on a horizontal axis, and the rotation is, see, the rotation will be seen in the vertical plane, but the rotation will be happening on a horizontal axis. There will be a little bit confusion here, so for confusing us he is giving us this term, okay. Now transiting is nothing but the rotation of telescope, transiting is the rotation of telescope, rotation of telescope, rotation of telescope in vertical plane, rotation of telescope in vertical plane, rotation of telescope in vertical plane on horizontal axis, on horizontal axis, and this horizontal axis we do call it as a Trunian axis. This horizontal axis we do call it as Trunian axis. So what is the question here? Rotation, see here, you can rotate the telescope about, the telescope can be rotated about the vertical plane, okay, on horizontal axis. Now see here, so he is asking on what axis this rotation of telescope will be happening. The rotation of telescope in the vertical plane, the rotation of telescope in the vertical plane will be happening on a horizontal axis called Trunian axis. So the answer will be of Trunian axis, okay. So when you transit the telescope, or when you are trying to rotate the telescope in the vertical plane, you rotate the telescope about a horizontal axis called a Trunian axis, okay. It is nothing but a Trunian axis, right. So moving further, latitude of a place is a triangular distance. So now see, if you observe, we do know what is latitude and we do know what is departure. Latitude and departure. Latitude is nothing but a length, okay, when it is having its projection, or when a line is having its projection upon north-south axis, and departure is nothing but the length when the line it is having its projection upon east-west axis. Now the question is about latitude. So latitude, we do know this will be happening on the north-south axis, and we will be observing this north-south axis on the meridians, given provided meridians, okay. So if you see here, from equator, now this is your equator line on the earth, this is your equatorial line on the earth. So from this equatorial axis, it will be moving towards north, or it will be moving towards south, okay, and that will be have to observe only on the meridian of a plane. So option 4 will be the correct answer, from the equator towards the nearest pole along the meridian of the plane, because latitudes have to be found out only on the meridians of the planes, okay. These have to be found out on the meridians, because the meridian will be taken as a respect, that means with respect to that meridian we will be finding out the latitude or departure, okay. So meridian of the place, okay. So latitude, meridian of a place, okay. The linear closing error that may occur while plotting a compass traverse is adjusted by, see, while we are drawing a traverse here, while we are drawing a closed traverse by using a compass instrument. Now see here, the traverse has came up to here, but the traverse is not getting closed. Why the traverse is not getting closed? Because of having some error, and that error can be found out. From taking the coordinates, okay, and those coordinates can be applied in transit and Bowditch rule. Transit and Bowditch rule, okay. By using this we can apply the corrections for latitudes and departures, and we will be able to close the traverse. Now the question is about here, the linear closing error that may occur while plotting a closed compass traverse is by applying this Bowditch rule, Okay, Bowditch rule. Okay, so Bowditch rule and transit rules are used for closing the traverse and for applying the corrections to these latitudes and departures. Fine. Now the RL of a floor of a building is 100 meters. The staff reading on the floor is 1.625. The staff reading when it is held inverted with the bottom touching the ceiling of a hall is 2.870. The height of the ceiling above the floor is dash. So this is actually a problem of leveling area. Okay, but that doesn't mean that doesn't mean that it should happen only with outer level or dumpy level. It can also happen with a theodolite also. So the point is here the RL of the floor is 100 meters. So I'll be calling it as a floor. Okay, so this is a floor. Staff reading on the floor is 1.625. The staff reading on the floor is 1.625. And the staff reading when it is held inverted on the bottom of a ceiling. So this is a ceiling here. So on the ceiling I have held an inverted staff. This is ceiling. And here I have using an inverted staff. And the staff reading on the inverted staff is 2.870. Now the question is asking about is the height of the ceiling above the floor. So he is only asking about his height. So simply add these values so that you will be easily able to get this is 1.625 plus 2.870. Add these two, this is 5, this is 9, this is 14, this is 24, this is 4.495. So check the options 4.495. Very simple here. Up to here the height was given and from here to here the height was given. So add these two heights so that you will be able to get the height of the floor. Very simple. Okay. Moving further, fine adjustment of a theodolite is done by. So generally the fine adjustment, that means a very clear precise adjustment will be done by using these tangent screws. Okay, clamping screws are used to clamp, clamping screws are used to lock. Okay, foot screws are used for leveling, that is centering the bubble. Focusing is for focusing the crosshairs and focusing the object. So the only screw that are used for fine adjustment are tangent screws. Okay, moving further. An imaginary line passing through the optical center of the object glass and optical center of the eyepiece. Optical center of object glass. Optical center of object glass and the optical center of the eyepiece. Now this is nothing but here the imaginary line passing through the optical center of the object glass and the optical center of object glass. Okay, this is your object glass. And optical center of the eyepiece. Here also you will be able to have this optical center of the eyepiece. So again, this is nothing but axis of telescope. You can see that is nothing but the axis of telescope. Fine. Moving further, in Bowditch rule it is assumed that the error is proportional to square root of length of a line. In Bowditch rule it is assumed that the error is proportional to square root of length of a line. If you take the transit rule, it is inversely proportional to the square root of length of the line, but here he is asking about Bowditch rule. So for Bowditch rule it is square root of length of a line. Okay. If n is the number of sides of a closed traverse, the sum measured in interior angle should be equals to, previously we have discussed 2n minus 4 into right angles. Right angles is nothing but 90 degrees. Okay, so this is 2n minus 4 into 90 degrees for interior angles. This is for interior angles. If you go for exterior angle, the exterior angle formula will be changed. For exterior angles, it will be 2n plus 4 into 90 degrees. Okay, so clear answer here is 2n minus 4 into 90. This is 2n minus 4 into 90 degrees, where n is the number of sides. What is the method used for measuring the horizontal angle between the lines more precisely with a theodolite? So see here, he is asking us to find out the horizontal angle between the lines more precisely. That means repeatedly we will be finding out the angle between two lines. Okay, so as to find out the horizontal angle here, and this method is nothing but the repetition method. Horizontal angle, okay, by repetition method, finding out multiple times in order to gain the accuracy is a repetition method. So the repetition method will be the correct answer. Okay, if it is of multiple lines, that is if it is more than two lines, then we will be going for reiteration method. Find out the departure of a line having the length of 100 meters and its reduced bearing is 30 degrees. So he is asking us about the departure, where the formula for a departure is L sin theta. The value of L is given here as 100 and the sin theta angle is given as 30 degrees here. So 100 into sin 30 half, this is 50 times. So the answer here is 50 meters. Check for the answer. This is 50 meters. Okay. Very simple question. Moving further. What is the sum of interior angles of a closed traverse? Already we have seen the sum of interior angles of a closed traverse of n sides 2n minus 4 into 90, 2n minus 4 into 90, 2n minus 4 into 90 degrees, right? The process of rotation of telescope of a theodolite about the horizontal angle is the process of rotating, this is rotating, it's not rotating, the process of rotating the telescope of a theodolite about the horizontal axis. So if you take the horizontal axis reference here, which we do call it as Tunnian axis, so when you take this Tunnian axis as the reference, and if you are rotating the telescope in the vertical plane, so and that too he is calling like 180 degrees in the vertical plane, yeah, fine. So the rotation is known as transiting, The size of a theodolite is defined according to the size of a theodolite will be defined, or it can be judged basing upon the horizontal base plate. Okay, so in that too, in this horizontal base plate, the lower base plate, it is attached with a main scale. Okay, where the diameter of the main scale will be judging us like what is the size of a theodolite. So it is only the diameter of graduated horizontal circle which is in the horizontal base plates. Okay, it's not the length of the telescope, it's not the height, it's not the vernier plane diameter. Okay, it is only the diameter of a graduated horizontal circle. The latitude and departure of a line is given here. The latitude and departure of a line are given. Okay, that is 78 and 45.1 meters, plus 78 meters and minus 45.1. So here the latitude is positive. Here the latitude is positive, and the departure is negative. Latitude is positive and the departure is negative, and this will be happening only in the fourth quadrant. Okay. This will be happening only in the fourth quadrant, because in the very first quadrant both are positive. In the second quadrant, first is the latitude is positive and departure is negative. In the third quadrant both are negative, and only in the fourth quadrant the latitude is positive and departure is negative. And see, whatever the line that is in the fourth quadrant, see whatever the angle that is in the fourth quadrant, the answer 30 degrees first quadrant, so not the correct answer. 150 degrees second quadrant, not the correct answer. 210 degrees third quadrant, not the correct answer. 330 degrees fourth quadrant will be the answer for this question. Simple. Okay, we have to check whether the given angle is in which area, so that we will be easily able to answer that. The ratio of linear displacement of a length of a traverse against the end of the line is subtended by 1 second of arc of a theodolite station is. See, this is very simple. If you see, this is a theodolite and this is a deflection angle for 1 second. Okay, and this is the length, I will be calling it as length L, and this is a radius here, radius of this bubble tube. Okay, now what is it here? The ratio of the linear displacement to the length of the traverse against the end of the line subtended by 1 second of arc of a theodolite station. Okay, for example, if you take this as a theodolite station and see, this is a R, radius of the arc. So generally we do know delta is equals to L by R. Okay, so this is L by R, wait, it will be coming in terms of radians. Okay, and this is L by R, that is the radians. If you convert the radians here, it will be 180 by pi degrees into minutes into 60 seconds. The answer will be coming out like L by R into 206265 seconds. Okay, corresponding to 1 second, that is 206, 300 will be the answer for this question, that is 206265. Okay, so that's what the answer here is. Moving further. The characteristic feature of a mining theodolite, the provision of dash telescopes at one end of at the side and the other at the top. So generally we will be using auxiliary telescopes for this theodolite. Okay, and for the mining telescope we will be using this auxiliary theodolite. So we don't no vernier theodolite will be there. It's not unsymmetrical or it's not symmetrical. It will be auxiliary theodolites, because auxiliary theodolite will be giving a good telescopic vision, and see, we will be able to zoom, we will be able to have a clear picture when you use an auxiliary telescope here. Okay, moving further, the distance between each degree of a latitude is 69 miles. This is a direct objective question. The distance between each degree of a latitude is approximately 69 miles. That's a direct objective question. The process of turning the telescope of a theodolite in the horizontal plane. So previously we have seen the rotation of telescope in the vertical plane, which we are calling it as transiting, but here the telescope is rotating in the horizontal plane, and that is called swinging. Okay. The latitude of a line is 100 plus C, very simple again here. So the latitude is given as negative, sorry, the latitude is given as positive and the departure is given as negative. The latitude is given as positive and the departure is given as negative. So already we have seen previously, the latitude is given as positive and the departure is given as negative. It is said to be in the fourth quadrant because it is first quadrant, second quadrant, third quadrant, fourth quadrant. In the fourth quadrant, we do have latitude positive, departure negative. Latitude positive, departure negative. That's what the point he has given here. Latitude is positive, departure is negative. This is 100 comma 100. Okay, which means that it will be making an angle of 45 degrees with respect to the north. Okay, which means that it makes an angle of 45 degrees with respect to north, and this is north now here, this is south, and this is west. Okay, and all the answers were given in terms of reduced bearing system. So the answer will be north 45 degrees west, north 45 degrees west. Even without writing this, or even without drawing this figure also, we will be able to answer that question. Okay. The process of telescope, the turning of the telescope through 180 degrees in the vertical plane. So rotation of telescope in the vertical plane is called as transiting. Okay. Moving further, the turning of the telescope in the vertical plane about 180 degrees. About the turning of the Theodlite telescope in the vertical plane. So rotation of telescope in the vertical plane, transiting. So multiple times this question came here. The most accurate method of plotting a Theodlite traverse is independent coordinate method. Independent coordinate method. Let f be the focal length of an objective and I be the stadia higher interval and d be the horizontal distance. So generally see, when we take a tachymeter here, the horizontal distance can be found out from the formula d is equals to ks plus c. Okay, where k is a multiplicative constant. Where k is a multiplicative constant, and we will be calling that k with f by I. The formula of k is f by I into s plus c value is f plus d. Okay. Now what is he asking here? The additive constant, where k is called the multiplicative constant. K is called the multiplicative constant and c is called the additive constant. C is called the additive constant, and this additive constant can be written as f plus d. So if you see here, f plus d will be the answer, where f is the focal length and d is the distance from the optical center to the vertical axis. Removal of parallax error in the theodolite may be achieved by adjusting the object lens and the eyepiece. Okay, because parallax error will be observed in the eyepiece. If I is the stadia distance, or stadia intercept, f is the focal length and d is the distance between the objective and the vertical axis of the tachymeter, the multiplicative constant is, already we do know the multiplicative constant is shown with letter k and additive constant is shown with letter c. Okay. So the formula we do know for finding out the horizontal distance is d is equals to ks plus c, where k is called the multiplicative constant. K is called the multiplicative constant, already we have seen. Okay, and c is called additive constant. But then our question is about the multiplicative constant k. So k is equals to we do know f by I and c is equals to we do know f plus d. So as he is asking about the multiplicative constant, the answer will be of f by I. Simple answer. Moving further, the turning of the Theodolite telescope in the vertical plane. So rotation of telescope in the vertical plane, we do call it as transiting. In a closer traverse, the sum of the north latitudes exceeds the sum of the south latitudes, and the sum of the west departures are exceeding the sum of east departures. The closing line will be in. So if you take a traverse here, okay, this is north, this is south, this is east, and this is west. And if you observe the question carefully, in a closer traverse, the summation of north latitudes, because latitude will be having its projection upon north, south, and departure will be having its projection upon east and west. Okay. Now what is this here? The sum of north latitudes are exceeding. North exceeds the sum of south latitudes, so they are exceeding the sum of south latitudes. So the sum of north latitudes are exceeding the sum of south latitudes. Fine. And what again he says here? The sum of west departures exceeds. Sum of west departures are exceeding sum of east departures. Right. So the closing error will be within. So the closing error will be within the fourth quadrant. And now what is the fourth quadrant if you observe? What is the fourth quadrant if you observe is northwest quadrant. So northwest quadrant will be the answer for this question. Okay, very simple. So here you can see this is exceeding in this direction, this is exceeding in this direction. Okay, because he clearly said the sum of north latitudes are exceeding, this north latitudes are exceeding south latitudes and west latitudes are exceeding east latitudes. So the line will be in between this north and west, so answer will be northwest quadrant. Simple.
So my dear students, for Ecet 2024 and Ecet 2025, Saimedha Koti Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi Saimedha Koti Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, ఉంటాయి, విత్ మెటీరియల్స్, వితౌట్ మెటీరియల్, ఆన్లైన్ కోచింగ్, టోటల్ మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద సాయిమేధ కోటి హైదరాబాద్ as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous Ecet examination questions. I wish you all the best. This is Mohammad Inzamam signing off.